Okay, so we are going to learn about isosceles and equilateral triangles. These are two special types of triangles, and they have their own theorems that go with them, some theorems and some corollaries. So we're going to cover that today. All right, so the first type of triangle we're going to cover is isosceles. And an isosceles triangle is a triangle with at least two sides congruent. So this triangle next to this is isosceles. And you can tell because AB and AC are the same. It has two congruent sides. And now we're going to label the body parts here. The two congruent sides are the legs. So you have legs. The third side that isn't congruent is called the base. So the base is the unique side. Opposite the base is what we call the vertex angle. This angle is the only one of its size in the triangle. And the only other body parts that I'm going to name, because they're going to come up in the theorems, are if you have congruent legs, the angles opposite those legs are also congruent. So B and C are congruent. Since they bracket the base side, these are called base angles, and base angles are congruent. So those are our basic body parts to an isosceles triangle. Okay, our second type of triangle that we're going to learn about is the equilateral triangle. Now your lats, remember your lateral muscles are on your sides. So equilateral means equal sides. It means all the sides are equal. So it's a triangle in which all three sides are congruent. So 1, 2, 3, all three sides are congruent. Okay, part C, equiangular. Equa means equal, angular means angles. So in this case, all three angles are congruent. So all three of the corner angles are the same. Okay, so just based off of the definition, there's some things that you can solve for on the problems. So example 1 says find x and y. You'll notice it is equilateral, which means all the sides are the same. Now, because the sides are the same, you know that x and 10 have to be the same. So x equals 10. So some of these you're just going to pull right off of the drawing. There isn't any math. Now, to do the y's, though, we have a y plus 3. I can't put it with x because it wouldn't be solvable, but I can put it with the 10. And since these are equilateral, y plus 3 is equal to 10. Put a box around it. That is your equation. And then you solve for y, which in this case is very simple. You're going to subtract 3 over to the right, and you get y equals 7. So don't forget to box your equations and circle your answers. All right, flip the page. All right, this is another example. This says find x and y if triangle ABC is equiangular. So if it has equal angles. So let's mark it that way. All three angles are the same, equiangular. So on this one, it's easier to start with y. Y and 52 are equiangular. So the measure of angle y is 52. That one you can pull right off the drawing. Now, to find the x, we have an expression for x at the top. And again, we can use the 52 degrees. And putting those into an equation, 14x plus 6 is equal to 52. Because this is equiangular. Okay, so now we're going to solve for x. So subtract 6 over to the right. 14x equals 46. Get the 14 off the x, so multiply by 1 over 14. You will be reducing some fractions, so I wanted to make sure we review that. So when you reduce a fraction, you decide what two numbers multiply to give you that number. So 46 is 2 times 23, and 14 is 2 times 7. Take a 2 out, and we know that 23 and 7 don't have anything in common. So x is going to be 23 over 7. Make sure you can reduce a simple fraction using your brain cells, not a calculator, because it will come up a lot. All right, so those are our basic two definitions for isosceles, equilateral, equiangular. Now we're going to do some of the theorems. First one is isosceles triangle theorem. That's the title, so you can actually use that title. And it says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So two sides being congruent means isosceles. So it says given triangle ABC, side AB is congruent to AC. So AB and AC are the same. So this is isosceles. And the theorem said the angles opposite the congruent sides are also the same. So angle B and angle C are the same. And base angles are congruent. That would be your explanation. Base angles are congruent. So if two angles are congruent, you get the sides. If the two sides are congruent, you get the angles. It goes both ways. It's a biconditional. All right, let's do the corollaries. So corollaries, remember, are attached to theorems, but they didn't have to prove them because they're considered a logical extension. So here's corollary 1. An equilateral triangle, so make all three sides of that equal, is also equiangular. So if it has equal sides, it has equal angles. Now I'm going to use the if-then arrow, which is the equal sign with the little arrow. And just on this one, I'll remind you, this is an if-then. So if three sides are the same, then three angles are the same. All right, and here's another corollary. It says an equilateral triangle, so again, we're dealing with sides that are the same, has three 60-degree angles. So if the sides are the same, all three angles are 60 degrees, 60, 60, 60. This makes sense because remember from a couple chapters ago, triangle sum theorem says that all the angles of a triangle add up to 180. And if I take 3 times 60 degrees, I get 180. So that makes sense. We're going to use triangle sum theorem a lot more in this chapter than we did in the last one. All right, flip the page. All right, last corollary. This is another corollary. This one says an equiangular triangle. Okay, so mark this. Our if is if the angles are the same. If it's equiangular, it's also equilateral, meaning it has equal sides. So this goes both ways. 3 congruent angles means 3 congruent sides, and 3 congruent sides means 3 congruent angles. All right, 4.2, theorem 4.2. This is the converse of the isosceles triangle theorem. Converse is a math word for reverse. It's the other way. And this says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So in the original, if the angles were congruent, the sides were congruent. I'm sorry, if the sides were congruent, the angles were congruent. With this one, if two angles are congruent, you get two sides. So it goes both ways. So here's our picture. In triangle ABC, angle B and C are the same. So those are our two congruent angles. And if that's the case, then according to this theorem, the sides opposite those angles are also congruent. In other words, the legs. All right, so let's practice these. So example 1, find x and y. When it says find x and y, find is the same as solve, which means you need to have an equation to go with your answers. So looking at the 3, I've got a y and I've got 2 that have x's in them. It would probably be easiest to start with x. The 2 angles, C and B, are noted as congruent. So I can take 3x minus 2 and set it equal to x plus 38 because they are congruent. All right, so we're going to solve for x. So subtract x to the left, add 2 to the right. You get 2x equals 40. And of course, 2 times 20 is 40. So x equals 20 degrees. All right, so we've got our x. And you won't always start with x. You have to start with what you can get and then use your answer to get the next thing. So for example, if I tried to do y, let's say I used A and I used B, I would end up with y equals x plus 38, and that isn't something I can solve. But because we found the x first, we can substitute the x in there, and we get y equals 20 plus 38, which is 58 degrees. So you won't always start with x, but you do want to start with whatever you can get first, and then use that answer to get the rest. All right, flip the page. Last 2 examples. Right. Now these are 2 triangles we do a lot with. You're going to see them again. All right, so our first one is if angle 1 is 35 degrees, find angle ABC. So ABC would be angle B, but we have to find 2 and 5 and add those together. Once we add them together, we've got ABC and we're good. Now it does say if angle 1 is 35 degrees. So first thing I want you to do, and on your homework, I want you to draw it and label it. Angle 1 is 35 degrees. Now using our theorem, ABD has 2 congruent sides, which means the angles opposite those sides are the same. So if 1 is 35, 2 is 35 degrees. And what do you know? I have half of what I need for my answer. So what you have to do on these is start with what you can get and work your way over from there. So the connection between the left triangle and the right triangle is this little intersection that they share at D. So I'm going to call the left side, the left angle X, and X and angle 3 form a linear pair. So how can we get X? Okay, here's how we're going to get X. Triangle sum theorem says that X plus 35 plus 35 has to add up to 180. So I'm using my 35s, and then I just made up the letter X to go in there. You can do whatever you want. I'm not going to spend time solving. We end up with X equals 110 degrees. Let's label that. All right, so now I have one of a linear pair, and the definition of a linear pair are 2 angles that share a side and add up to 180. So X is 110 plus angle 3 has to add up to 180. That's the definition of a linear pair. So we solve for angle 3, and we get 70 degrees. And I'm going to put that in here, 70 degrees. So that linear pair is how I got from one triangle to the other. Now I'm in the right-hand triangle, which is the one I need. And again, looking at BDC, 2 sides are the same, which means 2 angles are the same. So angle 5 and angle C are the same thing. So I'm going to call both of them Y. And then again, using triangle sum theorem, y plus 70 has to be 180 degrees. And when you solve for that, you get y equals 55 degrees. So now I'm ready for my answer. The measure of angle ABC equals 2 plus 5. So 35 plus 55, which means the measure of angle ABC equals 90 degrees. When in doubt, keep finding angles. Eventually, you'll get enough angles that you'll be able to get the angle that you want. All right, so B, this is our last one. A couple of your questions, they're going to put K's in your answer. So I want you to see how you work with a K. You treat a K like a number, but you can't add K to a number. It's got to stay K. Most of the time, if they give you K's in the problem, you're going to have K's in the answer. There are exceptions, but usually you're going to get a K. So let's look at this one. It says angle 1 equals K degrees. So I want you to label that K degrees. And again, we're trying to find angle ABC. So I'm going to show you that this is the same process. It's just it has K's in it. Okay, so like before, triangle ABD has two congruent sides. So the angles opposite are the same. So if 1 is K degrees, 2 is K degrees also, because they have to be the same. Now I'm going to call the third angle X, and we're going to use triangle sum theorem to put the equation together, which is X plus K again equals 180. They add up to 180. Okay, so we need X, so we're going to solve for X. K plus K is 2K equals 180. To get X alone, I'm going to subtract 2K over to the right, and I get X equals 180 minus 2K. So I'm going to put a little arrow there because I can't fit it in there. That's 180 minus 2K. Now, just like the one above, angle 3 and angle X together make a linear pair. So by the definition of a linear pair, they add up to 180. So here's my X, 180 minus 2K plus angle 3. Those have to add up to 180 degrees because they are a linear pair. All right, I need to solve for angle 3. That's the one I'm looking for. So I'm going to subtract 180 over to the right and add 2K over to the right. So I get angle 3 equals, and interestingly enough, the 180 subtract out. So angle 3 equals 2K. We're going to label that 2K. All right, now we are in triangle BCD. If two sides are the same, the angles opposite are the same. So angle 5 and angle 4 are the same. I'm just going to call them Y. And again, we're going to use triangle sum theorem, which says those three have to add up to 180. So Y plus 2K equals 180. And we're going to solve for Y. So Y plus Y is 2Y. So 2Y plus 2K equals 180. I want Y, not K. So I'm going to subtract 2K over to the right. So 2Y equals 180 minus 2K. To get the 2 off of the Y, you're going to multiply by a half. So put the whole right side in parentheses and multiply everything on the right by a half, which is the same thing as dividing by 2. So I get Y equals 180 divided by 2 is 90. 2K divided by 2 is a negative 1K. All right, so Y equals 90 minus K. I have angle 2 and angle 5, and those are going to add up to what I want. So here we go. The measure of angle ABC equals 90 minus K plus K. Of course, K minus K is 0. So the measure of angle ABC equals 90 degrees. So the K's did drop out, and that will sometimes happen on your homework, but usually not. Usually you will have K's in your answer. You treat them just like any other variable. All right, that is the end of the notes. Are there any questions?